we should be going live, I think. Are we? It's starting. Do you note that we have audio today? We should have audio going out to the stream as well. Yep. Okay, good. So, it's Friday night, and what better way to celebrate the end of a week than by doing more work? The same kind of work you do every day. So, what we have is this Toshiba Satellite Click Mini L9W-B. This is a tablet conversion PC. It's running on an Atom processor, and it's one of these things that you take it up and press this button, and now it's a tablet, and now it's a rather low spec laptop. So all the PC stuff is in here. I think there's a bit of extra battery in the base, and yeah, this thing is from 2015. I think that's roughly when the Google results start showing up for this thing, and it's not charging. Rather than charging, it just gets warm. And if I were to plan this properly, I would have gotten a USB charger in beforehand. But I'm going to do this right now. Let's just fetch the fancy Pearl charger, since we have one with a power meter, saving us the trouble to use my dodgy, horrible USB meters which don't work properly. So that's a charger, and there's a power cord, and yeah, that should be powered on. So let's just take some USB and shove it into this tablet conversion and see what it does. Last time I tried this, it just got warm. Click. So it is drawing power, 2 watts, and I believe it does, after a while, they give us some display just telling us that the battery is critically low. That's what it did the last time anyway. It used more power that time though. Has it completely died in the meantime? Does it not like my fancy Pearl charger? What's that drawing? 1.3 watts? That's almost nothing. Perhaps it'll take a while though, because I do believe the battery is completely dead in this thing. I don't think it's going to do anything. Oh, disconnecting the base. Stops it drawing any power at all. And now it started again. Okay. Does that mean it's charging the internal battery? I don't know. I've barely even played with this thing. But yeah, for the time being, it seems to be completely and utterly dead. So let's see what the chat's got to say for just a little while this thing perhaps puts a bit of charge in whatever's remaining of the battery, which I do believe is completely shot. Someone says the fluke caught fire today. That's not good, Kaido Fujimi. You ought to not make your flukes do that. You must have shoved it into something very high voltage. Ultra says you should do how to repair vlogs. To be honest, I think this would be fun. I am going to when I get around to it, but I have no money. Someone says audio reverb. Yes, that's because I've got a little tiny bit of audio going through my speakers because of the little issue we had the last time I did a stream where we had audio for like 40 minutes. Right, anyway, this thing seems to be doing absolutely nothing. Yeah, it's dead. So let's just pry it apart, because I already saw what it was doing when I had it sitting around for a while. So this is one of these plasticky things. If we put this in the light and press it, you can see it's plastic, not glass. So it's just going to come apart along the edges, and I think if we use a knife and some really worn out horrible plastic pry thingies, we might be able to get inside without doing too much damage. Where the hell is my knife? Oh god, oh, that's my knife. Right, so let's see what's the best starting point for this. We want to do it, it's probably got the least amount of locking around here, since there's just this big gunks of stuff there. Don't want to do it around the ports, too sensitive. Could do it up here, but I think it's going to be rather rigid since there's just a clean line all the way across. So let's start on the bottom. I think that might be a winning bet. Shoving metal into lithium-ion filled boxes is always a lovely idea. Oh wow, that popped out apart really easy. We're already getting there. Click. Oh wow, this is really serviceable. Huge locks on that, I love this. This is very nice. I like this thing. That's by far the easiest start on opening a tablet I've ever had. Click. Click. Wow, this thing is amazing. I love it. Now we probably want to move away from the motherboard first, since likely all our connectors are going to be, since we have a port here, our motherboards are going to be like there. The rest is going to be battery, so all our cables is going to run over there. So flipping it out like so is going to be probably the most productive starting point. Yeah, I can already see some wiring in there. Someone's asking, what's the issue? This thing does not charge. It gets warm, shows the ultra low battery warning, and never gets anywhere. So I'm thinking we just have a bad battery in it. I'm surprised that it's getting warm though. The warmth is not coming from the battery, but rather from the motherboard. So I'm not entirely sure what's up with that. We have a bunch of battery in this end. Perhaps we should start to go the motherboard end anyway, since it's kind of split there, and we seem to be having battery or some big mass right to the edge there. And I'd rather not shove my blade into battery. Maybe we can use one of these. These are completely worn out and horrid though. Oh yeah, that's coming apart quite nicely. It would be very nice to get this thing up and running. I don't own any like reasonable tablet, and this thing has an Atom processor which scores like 900 points on CPU mark, which is not that bad for one of these things. Yeah, we're getting inside. Let's you guys are looking completely underexposed. Let's remedy that. There we go. So we have some huge bunches of wiring. Big heatsink in there. I think there's just these two big wires here going to the display assembly, so let's just pop those out and hope for the best. This thing was amazingly easy to get into, very serviceable. I really like this thing, like just from that. This is such an easy tablet to get inside. It's just begging to have people inside it. It's such a dirty little slut. So just prying away the Kapton tape to flick those zips out, and snappy, and that's a liberated display. So this is actually a pretty decent display. It's like 1920 by 1200 according to Google, so that's a pretty decently high-res thing, especially for its age. I mean, a 2015 model. And there are the goodies. 1 million wires going into the battery. That's not really what I wanted to see. I would have been much happier to see basically 2. So what's our issue gonna be? We to start by just measuring the battery voltage. 3.75 volts, 20 watt hours, 5200 milliamp hours. That's... yeah, this is the part I was hitting inside. This is what I thought was a battery, but I think it was a speaker. What I was trying not to stab. But we clearly made a good decision going in over that since it came so easy. Right. Right away I can see this battery connector isn't completely in. It's just ever so slightly not in. Now it's in. I don't think that's going to be the issue, so we're just going to disconnect this and measure the voltage. So we have a bunch of reds, a bunch of blacks, that sounds racist, a yellow as well, and a white and a blue. So let's just grab a meter and see what we get. DC volts. So I'm going to bet that the massive chunks of red and black are going to be the positive and negative, all in parallel. 2.8 volts. So that's a quite discharged battery. It's not dropping though. Like, we just had it plugged in. If this battery was very, very leaky, I would expect it to be dropping voltage at some kind of a pace. And maybe it is. Let's use our fancy high-res mode of this meter. That is dropping. Right, so let's now, since we have such good access, we could actually measure it on the board there. Let's plug this back in and hook the charger up and see what happens. It was drawing some power, so we need to figure out if that power is going to the CPU to power the system, do something, or if it's going into the battery trying to charge it. So we'll just bring the charger back into view. This is one of the few legitimate uses for one of these Pearl chargers, by the way. Where's our charging ports? That's HDMI, there's our charging ports. And it's drawing a bit of power. Let us see what our voltage is becoming. This thing was supposedly not used for quite a while. So it is charging. Oh, you can't even see them easy, can you? To reiterate, it is charging. So it's probably sitting in that recovery mode where it's just feeding a rather low current to the battery in order to basically try and determine if it's leaking horribly and about to catch fire. I wouldn't think this battery is actually bad. The previous owner, I actually have a good fortune of being able to talk to them. This one was given to me. They said that they'd left it charging overnight and it didn't work. So that's confusing, because this thing should just basically keep on pushing a low current until the battery's roughly, like, slightly charged. And then it should go in high current mode and charge. Yeah, there we go. It's charging quickly. It's charging at 10 watts. So the battery management thinks that the battery is good now. We just had to wait for the voltage to come up. Wow, that's rising quite quickly. So this is rising a bit quicker than I would like to see, actually. Up until we get to about 3.7 volts, it's expected for this battery to rise rather quickly, because like, that's just how lithium-ion batteries work. They don't really drop much below 3.7, they just fall like a rock, so we have almost no capacity when the voltage is that low, unless it's really heavily loaded down. So I'm expecting this voltage to just kind of start leveling off at around 3.7. perhaps a bit higher, since this is actually specified for 3.75 volts. Must be some kind of weird chemistry going on. But it doesn't really seem to be slowing down. Let's just let that sit for a while and see what the chat's got to say. We're just waiting for the battery to slightly charge. Jaron Stripstein asks what's the problem with it. It doesn't charge the battery. Someone to the games says, do you have a flow or some other way of thermal imaging? No, I am not that rich. Jesus, what do you think I'm made of money? Yes, but think of the extra views for lipo cells at my basement on fire, Station 240 says. AdZ545 says, wonder what's under that metal shield. That's not real. That doesn't feel like a metal shield as much as a heatsink. It's going to be the Atom processor underneath that. What CPU? It's an Atom Z3 something something. Like if you Google, God, I don't know, whatever this thing is called. Where does it even say? If you Google Toshiba Satellite Click Mini L9W, you're gonna find out all the info about it. It's like a cheapo Atom CPU, nothing fancy, 900 points in CPUbenchmark.com. Workable, but not great. Oh, Alphabet donated €1. Thank you very much. Much obliged. That's €1 towards, I don't know, a thermal imager maybe. 400 more of those and maybe we can have one. People are talking about multimeters. I recommend the Brahmin BM869. Oh, is that the right number? Yeah, BM869, the Brahmin. I use one of these here at home and one at work, and they're lovely meters. Like, we just used the 50-phase in count mode to see whether the battery was actually discharging at no load, which is a very handy feature, and you have like a million more functions that you get than you get for with basically any similar price meter. I love this, great price performance. They chew through batteries though, so you want to use rechargeable lithium ion 9 volts if you use one of these, else you're just going to ruin yourself on 9 volts. Station 240 says FF is made out of cardboard like his house. My house isn't made of cardboard, it's just coated in cardboard. Mr. Chelu12 says hello from Romania. Hello. €1, don't spend it all at once, AdZ545 says. AdZ545 asks, and how dear is the meter? It's very dear to me. Very dear indeed. Hey look, a lamp. So do we have some kind of voltage growing in this? 3.85 volts, and it's rising slightly slower than it was before. But I'm not sure. At a 10 watt rate, that is a rather high rate of charge actually, so we should expect the voltage to be rising rather quickly. But yeah, I'm not sure what to make of this. Maybe we should just hook the display back up and see if it's going to do anything. Or It does have a micro HDMI, so it could just feed an external monitor, but then I'd have to rip the micro HDMI lead out of that camera, and I'm not going to challenge fate with my streaming card doing that. Yeah, let's just unplug that, see what the voltage does, then hook the display back up and see what this thing says. So the voltage is dropping quite quickly as soon as we disconnect the display. Display charger. The battery is completely cold though, hasn't risen in temp at all. So let's just hook this stuff up, hoping that you don't need to like disconnect. Hang on, we can actually disconnect the battery, reset the whole thing while we connect the screen up, and see if we get image. If we get image and it just keeps saying low battery, I'm gonna try and power this thing off of my lab power supply. See if it'll do anything. Okay, in you go. Ziff. Alright. In goes the battery. In goes the charger. This is a bit of a crappy lead, but it's what we have. These atom-based things suck a lot of power, so I would kind of want to feed it as much as I possibly can. So back to charging at 10 watts. And we have a low battery logo. Going. Did it just turn off? Did I rip the wire out? No? What happens if we try to turn it on? I think that's the power button. So we have backlights, but no picture. Now we have nothing. Backlight, but no picture. And nothing. Okay, so let's see what happens to the battery voltage when we do that. Keeping in mind it's drawing pretty constant 10 watts there. We don't need the 50,000 count mode for this. We'd be much better off with the quick refresh. Let's just shove that in there. Shove that in there, I said. Give me a reading. Come on. 3.9. This voltage is going up way too quickly, I do think. So when we turn it on, the battery voltage drops and then rises again. So I would wager it's just not happy with that battery. It seems to have a rather high internal impedance. It's going to be annoying trying to feed this from an external power source without soldering leads on there. But that's never stopped us before, so let's just solder some leads on there. Gonna want to heat up the soldering iron. That's a reasonable tip for the job. Soldering a go. Bonk. And we're of course going to disconnect both the battery and the charger. While we are soldering, I'm just waiting for it to heat up and pushing some current into the battery while we do that. And that's the beep of a heated soldering station. So out comes the battery, out comes the charger. This battery has a bunch of diagnostic stuff going into it, so I'm not sure if this thing's going to accept running off of just voltage basically applied to the pins, or if we're going to have to keep the battery logic connected while we do this. I'd rather not want to be messing with a battery connector. I don't want to disassemble this plug unless I have to. But let's take that cross that bridge when we get there. And Yeah, you're not going to see what I'm doing anyway. It takes forever if I'm going to be zooming the camera back and forth. Just believe me when I tell you that I'm soldering onto the battery connector. I'm just putting some solder across 2 positive and 2 negative pins. And now we can tack some wires on there and mess with this tip, because the soldering iron is not working properly, because it's an old piece of trash. I'm going to need some wire. Do I have any red and black wire? Probably, but I can't be bothered finding it, so we're just going to use green wire for positive and green wire for negative, because that's traditional. That soldering station. I've ordered a new handle for it, since I think that's the issue. That's one lead, and that's another lead. ADZA545 says, cut the battery connector off and use that. No, I'd rather not do that, because it's annoying to reconstruct if I have to reassemble it. And I do intend to repair this thing as a proper tablet if I can, since I like it. It is to be reasonably well built. It's not super worn down. The previous owner said it had just been lying around for most of it. Shut up, you fucking piece of garbage! Bloody hell. Moving on. What was I saying? Someone says we could all see the tablet's video output live if you use the HDMI though. Hey, that's a cool idea. That's a cool idea, chat. Let's actually do that before we start working on this thing. Let's see if we can feed video straight out of a thing into my HDMI capture card. We're going to lose the camera for a bit, but I think it's going to be worth it. Let's do an experiment. Let's just reconnect this battery. There's nothing horribly shorted out. There we go. Let's fetch my HDMI lead. I think this is the right kind of cable. No shit, we can't. We can't because we were close to making a mistake of that, because my audio is going through that camera, and we'd be out of audio if I disconnect that camera. So nope, we're not doing that. We're sticking to the plan. We're sticking to the plan. Stay the course. Stay the course. Right, so that means we are soldering some wires onto this. Let's just tin those. It was a good idea to feed video straight to the HDMI capture card, but alas, we are foiled. It was not to be. Alright, so this is going to be the negative going, I think it's the negative is for black wire. Going on there. And the positive going on there. Like so. 2 wires. Now we'll just fold those over, making sure not to put any stress on the solder joints, because those are basically going to fall apart if we touch them. And now let's verify the polarity of a battery. Just to make sure we're not feeding this thing backwards. And we're not. Red is positive, black is negative. So now we're just going to fire up the power supply in mode B, 4 amps, and make a huge mess with roughly 1 million wires to... Can we like do... Oh no. Let's like camera work. Let's do that so you have a chance of seeing what I'm doing. So I think, yeah, I realise there's a big camera box right where all the action is, so this is not terribly useful. Maybe we can like, yeah, do away with that. That's better. We don't want 7.4 volts, that's not 3.8. We want like 4.2 volts. Because that's 4.1, a shit ton of current, because that's what lithium batteries do. There we go. There are wires, and positive is positive, negative is negative, good. So we have, let's connect up the display again, fold that over so we have a chance at seeing what we are doing. And if this works, I think we're just going to resell this battery with some random cells I have lying around and see what happens. Which one's positive and negative? I'm going to have to mark one of them up. Positive, that one, so negative is that one. This marker is garbage. There we go, one marked up. So, if the battery is indeed the issue, we should be able to just hook this up and get a working device. You can see a power drawn over there on the incredibly underexposed camera. Right, here we go, power on. It'll draw some current, drawing less current. What happens if we press the power button? Now it's drawing no current. It seems to be trying to start, but not succeeding. Could be that we have too high an impedance in our leads to make it quite happy. I think that's what's going on. So let's let's put a huge electrolytic cap right across our wires here. I think that might do it. It's just for testing. So this is going to be like a real low voltage, so I think we have some good options. 2,200 microfarads, 6.3 volts. So I'm just going to crop the leads to the same length on this and basically just solder it on there. Reflow it, nothing fancy. It's just an ugly test. Noting that the output on the power supply is turned off, because else this would be rather sparky. thin those. Get rid of most of the excess, which we really don't need. That's good enough. And positive, I'll just fold these down so that we can fold the cap over the battery connector, like so. I think I just shove the soldering iron into the battery, but that's fine. So what this cap is going to do is lower the impedance of our rather dodgy power supply, which is going through about 1 meter of wire to get to where we want it. And then put some flux on there, because else we don't stand a chance soldering any of this. And my flux container has been pissing all over, so I have to wipe that off. And that's all the paper we have, but it's certainly sufficient. There we go. So, gob some on there, gob some on there. That's good. So if it doesn't start with this cap installed, it's probably a question of the mainboard requiring there to be a signal on all the wires coming from a battery. Okay, so the cap's in place, one of the wires pinged off, so I'm just going to solder that onto the cap instead, so we don't solder onto the mainboard unless we really need to. So got that on there, and that's on there pretty tight. And that's on the right way around. So that should make us good. If this doesn't work, we're going to have to do something about the battery to get it working. But we'll see. Can we perhaps get rid of some of that horrible glare? No, we can't. Oh well. Right, so it's just time to keep an eye on the current meter, see if it does anything different. So it's going to spike when we turn it on because we're charging the cap, and then it's going to settle and hopefully start drawing some current again when the tablet starts up like new. It's doing something. Blink. 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 So it's just blinking quicker now. That is some odd behaviour. I don't think it's maxing out the power supply. Could actually be that we have some sort of short on the main board that's preventing it from starting up properly. So let's measure the voltage across our cap while it's doing this and see if that'll lend us any clues. What are you voltage? 3.35. Hey, it's drawing a bunch of current now. Has it managed to start properly? The backlight is on. It's drawing 1.5 amps. That's a lot of current, and a very low voltage actually at the terminals, and that's stopped. Where is our voltage disappearing? That we shouldn't have over a voltage drop going in there. So that could very well be our issue. I think I have some dodgy leads here. Oh yeah, this is a dodgy lead. It's got this spinny banana plug thing here, so we'll just like solder that in place. Or we just grab another lead because that's a bother. ZX8401 says it's odd that it has enough brains to display something but not to boot the OS. I don't think it's actually like booting properly now. I think it's just basically crashing. So that was our black lead, that was a bitch. Here's a blue lead which has the spinny thing on the banana plug soldered, so it's not going to make a horrible connection. So let's just hook this straight into the power supply and see what happens. That should fix our horrible voltage drop issue which could be causing the boot loop. Let's try it again. Power. So now it's drawing something and it thinks low battery. That's odd. Do we still have a voltage drop issue? Perhaps it doesn't think a low battery, perhaps it thinks broken battery. Like, I want to do that again and keep an eye on the voltage at the capacitor. So I'll just let that discharge and try again. Let's see. 4.25 is probably, hopefully going to start drawing current in a moment. Oh, that dipped very low. 3.98, that's a good voltage. That shut off. So I think what's going on is it's not happy not having the data lines going to the battery connected. I think that's the issue. So yeah, that's not working. What we could do is disconnect the wires, the data lines to the battery, or disconnect the positive lead to the battery. I know we kind of can't. Like, I'd like to feed this with an external power supply while having the battery protection circuit properly connected. And I don't think that's really going to happen without a lot of mongering. Because a trick you could do, I'm going to show you in a second. A trick you can sometimes do when you have something like this with a bunch of data lines is you just disconnect all the positive leads and plug in your external power there. But I've seen in some of the new battery protection circuits they actually have some stuff referenced to the positive and others might have some stuff referenced to the negative. So it's not really going to work properly doing that in many cases. So I used to do that on older stuff, but I've stopped since success rate has declined. So let's just get rid of this and get the battery out and see what's really going on there, because I think at this point everything just points towards the battery, because the motherboard seems to be operating quite happily. It's not drawing a ridiculous amount of power, and let's just flow that a bit nicer. There we go. You need to remove the excess tin. Yeah, the motherboard seems not to have a short circuit. It seems to be trying to detect the battery and failing. So we're either dealing with a bad battery, which is most likely, or we're dealing with bad battery sensing of a motherboard. Where is my small screwdriver? This place is a horrible mess. Oh god, the white balance on this main camera is absolutely horrible and overexposed for once. Jeez, what the hell is this white balance set to? White balance. Auto. Is that good? No. Is that good? No. Is that good? That's pretty okay. That looks a lot better. So out comes the battery, which of course was the obvious culprit to begin with. I just wanted to mess around a bit before we got there, because this is just for fun. This is not for profit. I'm not on the hour doing this. So that plug goes away, whatever you are, because it's in the way of a battery. Note that the battery is screwed in. It's not just glued in. Ah, it comes out. I am in love with this device. It has a replaceable battery. Ah, look at that. That's beautiful. Ah, Toshiba, I love you. This is amazing. Thank you. Thank you, Toshiba, for doing this. Thank you for having an easy-to-open tablet with an easy-to-replace battery. Thank you. Ah, that's heartwarming. So let's just absolutely rip into this battery and see what's inside. Since I think it's basically dead anyway. What do we have in here? Plastic and cells. I think this looks like a bit of a plastic cover, so if we just peel this a bit, we can basically get our cells. Rip, tear. Fuzi Allah says, shorts on the battery connector. Yeah, there are shorts on the battery connector between positive and positive and negative and negative. There are several of these pins are in parallel. The 4 outermost ones and the 4 outermost ones on each. The 4 outermost ones on each side are just connected in parallel. So just gobbing solder across them doesn't make a difference because they're just going to the same copper pad. So thank you for your concern, but there was no need this time. Right, let's see how to properly get inside this. This is obviously the cover for the protection circuits. Why did that go out of focus? We need to probably get slightly brighter still. So this ought to just pop out with the aid of a metallic object shoved into the lithium battery. Snap. Come on. I don't think this is even glued, it's just snapped. Come on. Come on. Let's use a plastic thing. I think that might work because I can use more violence that way. We don't want to ruin this protection circuit because I intend to recycle it. Oh, is that actually glued? It's not glued. It certainly does not look or feel glued. Come on. There we go. Rip and tear. Just use more violence. Oh no. It actually wasn't even glued. It was just snapped. Snapped in place. So this is this thing is a tablet which is easy to disassemble. It's easy to get the battery out, and it's easy to take the battery apart. What's going on? What's going on? This never happens. So that's a battery protection board. We do have 2 fuses there. I think the fuses could be thermal fuses, a bunch of writing on them. So we could just measure those. There's a decent chance just one of the cells has shorted out and is dead. And the protection circuit is picking up on that. Let's just measure the voltage across each of these. Nothing there. Nothing there. Let's measure resistance. I start with voltage because I don't want to do a resistance measurement in case it's open circuit. That's pretty close to what's there. Probe resistance, almost nothing. 0.1 ohms, so that one's fine. And the other one, 0.1 ohms, yeah, those are good. So let's measure our cell voltages, and they come in on the big giant tabs. That one, 3.645. The other one, 3.645. So I'm betting these are just connected in parallel, right on. Yeah, there doesn't seem to be any protection mechanism separating these batteries. So for all intents and purposes this battery looks fine. So that's odd. Perhaps we should try just manually charging it. Although I don't like the fact that we're back down to 3.64 volts. Like, that's dropped quite a bit since last. Then again, the whole thing about this could be that the customer has used the wrong charger to this thing. Because I noticed when I was letting this thing sit hooked up to a pretty cheap 2 amp charger, the mainboard was getting really warm. It was using a lot of power just running the CPU to show the low battery thing. If the previous owner of this thing, I keep calling them customer, but the previous owner, if they were using a cheaper charger which wasn't able to provide enough current to both run the rather warm Atom CPU and charge the battery at the same time, they would have experienced just this thing not ever taking a charge. And the charger I used wasn't very good either, nor was the cable, so it wouldn't have been able to put out anywhere near as much power as, for instance, this Pearl charger. In fact, my charger was drawing about 8 watts from the wall, which would be like 5 or 6 watts going into the device, which is barely any charge rate at all given how hot this thing was getting. So really, my troubleshooting mind right now is telling me to just put this thing on charge overnight and see if it works in the morning, because I think there's a very good chance there's actually nothing wrong with this. And it's just for some reason it's just producing a bunch of heat in the CPU while it's charging, which is dumb, of course. But yeah, if we just leave it charging without the screen connected, it should just probably, I think this is just going to take a charge fine. That is, however, going to take a while, of course. It's not a very interesting stream. So in that goes. And of course, not having the screen connected and turned on is also going to increase our charge rate. In that goes, and it's charging at 10 watts. Perhaps I even have a slightly shorter lead available. Perhaps it can charge even quicker. Let's give it a shot. The lead I'm using is long and of decent quality, but very worn. This is a short, crappy lead. Let's see what it does. So it's sitting at 9.5 watts with that one. And this one does the same, basically, but it's shorter and neater, so we'll use that. 9.5 watts is probably the current limit on the charger in the device. And if we measure the voltage across each cell, 3.811, 3.808. And that makes perfect sense because this one is slightly further away, and there's going to be more voltage drop to that one than the first one. And at the main board we have 3.93. So there's quite a bit of voltage drop going all the way over there. I don't like the fact that this cell is getting charged quicker and discharged quicker. That means in all these batteries, this cell is seeing high load, it's going to fail first, which is a bit of a bad design. Curiously, this thing doesn't seem to be getting hot anywhere except on the battery charger, which is good. Perhaps it's just not starting up properly without the monitor connected, which is a good thing for our purposes. So let's basically check out the chat before I just leave this thing, because I don't think there's going to be anything left to report tonight. This is the next step in my troubleshooting procedure, just letting this thing sit open for a while with no screen connected, see if it charges properly. The battery's probably going to be pretty garbage anyway, and I probably wouldn't replace the cells in it, but yeah, I don't think we're going to have to do that to make sure that the main board works, because I'm obviously not going to fix the battery if there's some horrible issue on the main board making the whole thing worthless anyway. So yeah, we are checking the chats, and then we're going to sign off. Oh wow, 76 watches. That's nice. So where did I leave off on the chat? There we are. ZX8401 says no tiny reset button on PCB. I have no idea, I'm not going to see anything on there. Quicker to just disconnect everything. Adria Garcian says, have you proved these leads? I have no idea what you're referring to there. Fuziala says, is it the same voltage on all the red leads? And yes, of course, they're all in parallel, like you can't. Well, let's use the fact that this camera does the fancy zoomy thing, the good thing about it, to show you how this battery connector is wired up. If I can find it, there we go. Prepare for warp speed. Boosh. So that's our battery connector, and as should be rather obvious right now is we have, come on, frame. We have 4 black leads and 4 red leads and 4 leads of various colours, and all the 4 black leads go to the same pad of the PCB, and all the red leads go to the same pad of the PCB. They're all just connected in parallel. And we're missing a chip. It almost seems as if a few of these cold leads might not be used. They are going to vias going somewhere, so maybe they're not related to this chip. But I would wager perhaps there's like a model of this which has some kind of battery protection on board, which they didn't bother with here. But yeah, there you go. These are in parallel. Let's unzoom this thing. Warp speed the other way. There we go. Someone says, that is more serviceable than an iPad. Yes, indeed. Join Anonymous says, actually most cheaper Android tablets are like that, which is strange. When you go to more expensive Samsung etc. models, these are a pain in the ass. That is entirely true. I like these. I even like this whole thing, the broken tablet of creative accomplishment. Creative indeed. This thing is so worthless. I have no idea. Like, this is Ching Chong i10. Some atom in this as well, but basically unusable since the screen is cracked. But also very serviceable. A shut up soldering iron. Adria Garcian asks, what are those small wires? Temp sensor, referring to the ones on the battery, and yes, the two tiny wires on the battery are the temp sensor. They're labelled TH2, so there's going to be a temp sensor somewhere around there. Etsy545 says, could you power it up minus the battery just to confirm the problem does not go deeper? I don't think this thing's going to start without a battery. These things never usually start without a battery, so I'm not even going to bother. ZX8401 says, I would hardwire the battery to a safe lithium charger. I don't own a safe lithium charger. If this thing goes up in flames, I don't quite care. Basement's made out of concrete, it's not going to go up in fire. Alphonse Jean says, still in the basement. Yep, because it's going to take months before I have the middle floor of this house sorted out. That background vibrating noise though, yeah, that's my soldering station. It's a piece of garbage. It's a very old OU 2901, which is basically just slowly falling apart. Good evening, says Sakibugger. Good evening, Sakibugger. You have sadly missed everything, and that's the end of the chat. We've been going for an hour. This thing is still charging. Let's check the battery voltage, and maybe we'll give this thing one last shot of firing up. 3.972, and it's slowing down. That's good. I wasn't liking the fact that the voltage was rising very, very quickly, because that's a sign of a battery which has high internal resistance and is not going to work properly and need replacing. But the fact this is leveling out is a good thing. So, yeah, a part of me wants to just hook up a screen right now and see if it gets any further, but since we've been charging this battery at such a low rate of just 10 watts 2C for such a short time, I don't think we actually have enough in here to allow the tablet to start up properly. So sadly, we're going to have to end this on a cliffhanger. Hopefully I'll have the time to stream it when I actually get this thing running, if we get it running tomorrow or something. Yeah, gonna have to leave you there. Good thing is, let's just do a bit of meta. I actually have a bit of a fancier streaming PC going. Oh god, that is so underexposed. Let's fix that auto exposure, which is still going to be too dark, but oh well. Let's see. There we go. We have something fancy with an ancient graphics card in there. but that's replaced the horrible PC I had before with 2500K. I think this has like an Intel 4770K. Certainly not high-end by today's standards, but a lot better than a 2500K non-overclocked. So we're getting a bit better quality, and I'm aching to use this thing. Where's that supposed to be pointing? Like roughly there. So yeah, I'm gonna have to thank you guys for watching. Make sure you enjoy yourself, and yeah, oh no. No. Let's not do that. Cancel everything I just said. Let's go on a further adventure right now, because I forgot we have a base, and this thing draws power. So I think it's worth taking apart just to measure the battery in this. So you guys are in for a treat. Let's just shove this slightly to one side and take apart the keyboard battery thing as well. I'm actually just curious to see what's inside there, because they don't really make it very clear what's going on. Like they just it came with a sticker which I peeled off, which just said 2 times battery equals 12 hours, and yeah, this is 2 times battery, right? But I think what they meant was there's also battery in the keyboard. I'll leave that in frame in case it changes. And this thing is too massive to just be an empty keyboard box. So let's see what we have. I think we're basically going to have an identical battery. Perhaps this is just like a power bank which charges the EV tablet. I would not at all be surprised if that's the case. It does have a USB port, like a Type A on the side, so this thing could potentially just also act as a power bank. That would be kind of cool. Like, just out of power? Let me just bring out my laptop keyboard to charge your phone. Laptop keyboard saves the day. How's this thing come apart? Let's use my witch-like fingernails to just rip and tear. There we go. Snap, crackle, pop. Crunch. Come on. Ah, come on. Oh yeah, I can see a battery. I have spotted a battery. My witch-like fingernails have been defeated. Come on, snap, crackle. Oh, that's just going to be a shitload of snaps around the back. Okay. This thing is not coming as nicely as the PC parts. Are there perhaps screws in the feet? I think there are screws in the feet, so let's not rip this thing to shreds before taking these guys off. Are they coming off nicely, or are there going to be issues? There are going to be issues. I'm pretty sure there are screws underneath here. Come on. There are screws underneath here. Now I just need to get these off without completely destroying the adhesive, which I have already done. Oh well. So it's kind of on the inside, so we can start in that end for that one. There we go. No wonder my pure violence wasn't working out. We were missing some screws, and these are longer than the others, so we need to remember that. The long screws go in the back. Let's not cause long screw damage on this. That would make Lewis Rossman mad. Snap, crackle. Ta-da! Another battery. Is this like just an identical battery? This is model number T8T2. And what's the one in the actual tablets? T8T2. So we have two identical batteries. That's very good. So we have a bunch of circuitry in there as well. Wow. I would not at all be surprised if this works as a power bank. So many inductors here. I think this thing just is basically its own freestanding thing, except it doesn't have a charge connector because it gets it through the tablet and this thing, which is pretty dumb. I would really want to see a micro USB on here, but there's not even a footprint. So let's see what voltage we have in this thing. If this battery is any good. Oh, we have waiting. That's that's odd. That's probably to just stop it from tipping over when you have the display folded back. Why didn't they just put in a bigger battery? So what do we have? 0.7 volts. Well, that's not good. Do we have anything at the USB port? Nothing. So this battery can probably be salvaged as long as we don't bother with the protection circuit. So I'm just going to put this on a manual charge. Because if you've been watching Big Clive recently, you're going to know, or rather have been informed of by Big Clive, who is not a scientist, that lithium batteries are generally okay as long as they haven't been reverse charged. And since this battery is not a series configuration but a parallel configuration, and it has a positive voltage across the terminals, it hasn't been reverse charged. I think let's just verify that. It really shouldn't get reverse charged. Oh, why is this impossible to measure now? Come on. Bloody hell. Let me measure this thing. Ah! Negative, positive. Are we not making a connection? What? We're not making a connection. Is that is the 0.7 like sort of a capacitor here? How are we not getting voltage? What? I am now confused. Click. Oh, yeah. You can't see the meter, but it's not been reverse charged. We have positive 0.77-ish volts of this. So that means we don't have any horrible leakage in here, because if we had leakage by the cell being damaged, it would have emptied itself to zero by now, because the amount of energy stored in a lithium-ion battery that's sitting at 0.77 volts is incredibly tiny. There's almost nothing in here. Like if I were to stab this thing with a knife, it wouldn't go bang because it's so drained, it's so empty, there's no potential energy in here. And there's almost no lithium in one of these either. So, as long as I get inside this thing and bypass the protection circuit, charge the cells directly, this thing is going to take a charge and it's probably going to be fine. So let's just get inside this thing as well. Sharky1717 says, "Don't spill the glass." Ooh. Whoa, 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 whoa. Oi, whoops. When I'm at work, I usually just have my coffee cup sitting inside like a 60-inch TV, just inside it somewhere. I'm not afraid of liquids. I'm a pro. Alphonse Jean said, but they sometimes fail catastrophically. Be careful if you're going to try to salvage a battery overnight. That's the thing. They fail catastrophically when they have the copper like stabby bits inside, and those don't show up when you charge them, they show up when you discharge them. So if this battery was to be a danger, it would already be sitting at 0 volts and be draining itself. But the fact that this battery is sitting stably at 0.7 volts tells me, as someone who is a layman, and you shouldn't take my advice on this, but that tells me that this battery is not damaged, and this battery will take a charge fine. It's probably not going to be in perfect shape, but it is going to work, and it is very unlikely to catch fire. And I'm going to prove this by using this device. People in the chat are telling me to be careful. Nah. I'm confident enough in this thing not catching fire. So how did the latch mechanism on this work? It was really odd. Where did the latch mechanism go? There it is. This thing. Oh right, this thing latches on in a way which makes it impossible to disassemble gracefully. Well, that's a shame. We'll just have to use more force then. Rip, tear, smash, destroy. Let's use our knife, shove it inside the lithium battery, unhook the cover, click, and I will just, and I will do it on the other side as well. Then we'll use brute force. There's nothing really right at the edge of that, so we're fine just violencing this. There we go, snap, crackle, pop. Rip, tear, destroy. There we go. We are inside, so let's see if anything's blown, if both cells are still connected, if the protection circuit has anything in particular to say. Yeah, we have more voltage there, 1.57. That's even better. 1.57, 16, 1.5716. So that's even better, because the battery is critically discharged. The protection circuit is probably not going to want to charge this ever again, but I think it's going to take a charge just fine. 1.5 volts, I'm still not worried that it's going to have any kind of leakage in it, since it still has basically no capacity inside. There's nothing there. So it would have, if this thing was prone to failure, it would have discharged itself to 0.0 volts at this stage, and if this was setting at 0 volts, like flat out 0, I wouldn't touch it. Like, that would tell me that this battery is bad, this battery is going to go up in smoke if you try and charge it, because it's just going to turn any power you put into it into heat, basically. So let's just put this on the lab power supply. I think these batteries are just straight up in parallel through the fusey thingies. Let's verify that. Between there we have 0 ohms, and between there we have 0 ohms. So I can just hook my probes onto one of those batteries, and we're fine. I'm of course going to charge at a very, very low current. Let's do like 10 milliamps. Because that's the lowest this thing will go when it's in a good mood. This thing goes to less than 10 milliamps when it's in a bad mood. We'll even, like, let's just measure the current coming out of this thing. My lab power supply, a TTI EX7, EX752M is not really built for very precise stuff. We need to turn the output off, else we're going to blow the fuse in the meter. And that's what, 7 milliamps ish, depending on how well I clamp the probes. We can do a bit more since it's such a big battery. 20 milliamps. I don't really trust the meters on the super low range on this power supply because they keep going kind of out of calibration since it's so humid in here. So that's fine. We'll turn the output off again and clamp onto our battery. Zoom. B2 negative. Clampy. And let's make sure those are actually correct markings because I don't want to accidentally put this on backwards. Yep, they're correct. Are they correct here as well? Yep. So we'll put the red probe on. We'll make sure the red probe is properly insulated and put it on there. And now we're charging. 1.6 volts, 20 milliamps. Let's have a look at the meter. Zoom, zoom, zoom. There we go. So if we measure across the other battery, we have a voltage that's very slightly climbing at 20 milliamps. So this battery is going to charge just fine. Mark my words, this is not going to be a burning hole in the bench tomorrow. And the battery on the tablet itself has reached, it's still sitting at about 3.95 volts. It's not getting warm, despite charging at almost 10 watts, 9.5 it's reading that. So really, I think this is going to work fine. I think the reason the previous owner discarded this thing was because he wasn't using a charger that was strong enough to actually charge the battery while the CPU was doing the weird heaty-uppy thingy and the display was on. And this thing was, of course, not working because the voltage in the battery was so low that the protection circuit had disabled it. The protection circuit might keep disabling this. We actually don't know if this is ever going to work, since the protection circuit might just not kick in which case I'm going to try desoldering the cells, putting them back on, crossing my fingers and hoping that it's going to work by doing that. Shut up, soldering iron. But right now, all we can do is the soldering iron. This soldering iron can die now. It's turned off. So all we can do now is wait for these guys to charge overnight, and hopefully I'll have time to get back to you on these. Let's check the chat one final time before signing off for real. Karata says, you said you would stop now. Now I have to choose between you and Rossman. I do streams much more rarely than Rossman does, so clearly my stream is superior of quality. Have a fire extinguisher ready, Jono says. I always do. Neo asks, can you speak Finnish? No, I can't. Plenty of people are saying get the pie dish. I don't have a pie dish. I'm more of a daredevil. Or rather, I have my concrete floor where I usually put things I'm afraid might actually catch fire, but I'm not afraid these are going to catch fire. They're in too good shape. This guy's up to 2.3 volts already. It's fine. Odds545 says, video in the morning, question mark? No, I do not get up in the mornings on weekends. Jesus Christ, what do you take me for, a normal person? No, I'm going to be sleeping till 4 in the afternoon and then do nothing for the rest of the day. And maybe do another stream of these like late in the middle of the night. But yeah, there we go. We are done, and I'm going to note that we had audio of the entire stream this time. So you guys take care and make sure you enjoy yourself. Someone's asking me about selling an i5 laptop. I don't have an i5 laptop for sale. I have like a couple of trashy i3 ones. Send me a PM if you want like a first gen i3 laptop for like way too much money, because shipping here is retardedly expensive. Good night.